Swayam Prabha. Digital India. Educated India.
Role of stocks. Stocks characterize state of the system. It provides snapshot status of the system and helps data to make, provides data to help make decisions. So, snapshot status means to make any decisions you need some information. For example, if you are flying a plane, you need to know its altitude, you need to know the wind speed, you need to know the say outside and inside temperatures, you need to know the the actual ground speed and what is the speed at which you are flying, the altitude, the direction, the bearing. You need various information. So, all the information that you need to make decisions that provides the state of the system at any point in time. Where is the aircraft? What all characterizes it? So, all those things become the stock because they provide data to make decisions, whatever the data may be. So, if you are going to use it, that becomes a stock. So, what else? If you are a production manager, then you need to have information about what is the current inventory on hand, what is the expected demand forecast, what is the expected order that is in pipeline that you ordered, we are not yet received, what is the current cost of the raw materials, how much raw materials you need to make this current production, how many workers are there in the factory. You need to know all the information to make the correct production decision at that point in time. So, all those information can be classified as stocks. That is the characterized state of system. So, in any other course, if you are saying that okay, this is defined as state of system, that means you characterize as stock. Stocks provide system with inertia and memory. Stocks only change through rates. What I mean by inertia and memory is that it accumulates past events. Like in the previous example, once the water level reaches the desired water level, it does not disappear. It just remains there forever until there is an outflow. If system does not have an outflow, it is not going to change. You can simulate it for how many ever time period you want, the stock remains. So, that is what I mean by saying that it provides memory. Inertia in sense is not going to change until there is some change in the stock flow rates. If flow is always 0, the value of stock does not change. Only if flow changes, then that forces the stock to change. So, in real systems, where does it help? For example, if you want to model the amount of ozone in the atmosphere, even if we stop the production of all say ozone producing equipments like shut down CFCs and other stuff, refrigerants, but still the current ozone that is accumulated will continue to remain there. That stock does not disappear. Even the current rate of release of ozone or CFCs, ozone depleting CFCs, you stop, your flow stops to 0, but your stock still continues to have that value. Right. So, that is what is called as memory. The stock is something which characterizes that state of system. It has to change only if some external forces apply, otherwise not going to change. Stocks are source of delays, like all delays involve stocks. Like if I want to, an example like in courier, suppose sending any package through FedEx or UPS or whatever courier, it does not reach instantaneously. You send it and after a time lag it reaches. So, until then the package does not disappear, it is there in the system somewhere. So, you can say okay, packages in pipeline as a stock, so that the matter is conserved. So, whenever there is delays involved, that means that information or that order or that material has to be there somewhere. So, whenever there is delays are involved, it means that stock is there somewhere, and after say the package is delivered, then that package in pipeline gets reduced. So, we can use it to represent the difference between the inputs and outputs. So, what is a delay? Delay means output lags behind the input, right. In a delay, output lags behind the input. So, until then things has to be remain somewhere. So that we characterize as a stock. That's a simple definition of delay output factor input. Stocks decouple rates of flow and create disequilibrium dynamics. It also absorbs the difference between inflows and outflows. Stocks characterizes state of system. That's an important point. Stocks provide memory. Third, we saw delays involve stocks. What we mean is delays. Delay means output lags behind input. So if I have say letters dispatch and then I have letters delivered. So delivered will typically be whatever letters were dispatched some periods earlier, or whatever letters dispatched today will be delivered say some L time periods later, or say 1 week later. So 1 week worth of letters has to be there in the pipeline. So we can have a stock called as letters in pipeline. This becomes your stock. Of course, these other two becomes your delays. Or as soon as you put raw materials into the shop floor, it doesn't become finished product. It spends some time in the shop floor. After end of a week or end of a day or end of a month, it becomes a finished product. Right? The raw materials after a delay becomes a finished product. So until then, until during the production process, those are the kind of raw materials is available within the shop floor. So delays involve stocks. It is not that everything, whatever letter dispatch has to come as letters delivered. It can be completely different things. Let us look at it as an example. Decouples rates of flow. So let us see. Let us have a stock of say food grains. So what will affect the stock of food grains? How will it increase? How will it decrease? So just simply let us call it production rate. Let us call it consumption rate. Production rate, consumption rate. As consumption rate changes, the food grains change, reduces. As production rate increases, I get more food grains. The production rate comes down, I get less food grains. But this is not a delay. It is not that whatever I produce after some time I consume, though it might happen. Production and consumption are controlled by completely different things. So what do you think affects the production of food grains? As you can see, completely different things can govern your flows and rates. But end result is what you are interested in, how much food grains we have. Just by mapping it out gives us some better sense, because the rainfalls follow some patterns and various other dynamics affects it. But eventually, of course, indirectly, how much you are willing to invest, etc., may be dependent on how much has been consumption rate in the past. Based on that, they are going to make some decisions, or some feedback does occur. But this talk has helped distinguish between these two key things, though linked is their difference get accumulated here within this particular stock. So to identify stocks, we can use things like, the difficulties when you look at a system, how to identify stocks and flows. We can start using the units of measure. Stocks are quantities and associated rates are same units per time period. That is quite simple. If you have a stock, for example, if food grains are in tons, then production also has to be measured in tons per time period. Say tons per year, consumption also should be in tons per year. So whatever the units of stock we have, the same unit should the flows also should have. You can remember because underlying you are having a differential equation, right? So the unit should match. You can't just subtract things which is has no unit. Units mismatch cannot occur. Snapshot test. This is like imagine you are freezing a scene. In the sense that is you remove time from the picture and whatever is remaining you see those are the values of stocks. So these can be both physical or it can be informational or it can be tangible as well as intangible things. Both can occur in this when you freeze the scene. Like when time is stopped, population is known, not the birth rate. Just look at the rate, you need to look at two different time points. So what you can see is actually the population, or if we stop the factory's production, you can see the amount of inventories at various points in time, but not the production rate. That's what I mean by saying that when you freeze time, what happens. Stocks can be physical quantity information or even memories and beliefs, right. So what is the expected orders per week? What is the expected price of onions? So we have some mental beliefs which are accumulated, that also will be calculated as a stock. What is the say employee morale? What is the inflation, expected inflation? So those are again values that we have in kind of what can you say? This forms part of our memories and beliefs, which also is a stock. As I told, stocks gives us memory. So all memories can be modeled as a stock. Choice of time units must be consistent. Like the agriculture example, consumption can't be in tons per day, while the production is in tons per annum. Simulation won't work. The unit should match. Flows can be positive or negative. Please remember that we are just dealing with a simple simulation. It has no extra logic built into that. It doesn't. It is just a variable names for it. So just by looking at the variable, you may have a sense of direction of positive. This cannot go negative and things like that. But for computer, it's not going to do anything. You have to be careful in defining whether the sense of direction is positive or negative, and accordingly model the system. Contents of stock flow network is conserved. So whatever leaves the stock, leaves the flow, kind of goes into the stock. Whatever stock drain, it goes into the next stock and so on. It doesn't just disappear from the network. So we have to remember that. Inventory of soft drinks. What do you think, stock or flow? It's a stock. What could be its units? Bottles. Procurement of soft drinks. So flow, what could be its units? Bottles per some time period. So if you want to, the shop is buying it every say week, you can put a week. Bottles per week. Assigning homeworks in a course. Flow or a stock. There is only two. You guys are. I mean, some half of you have to be correct. See, let's look at the word is assigning homeworks in a course. So it is flow. That is units. Let's go to, let us look at questions per week. There is an assigning homeworks comes as a rate. The number of homeworks due, that will be a stock, or number of uncompleted pending assignments. Number of pending homeworks will be a stock. So as and when assignments are given, that stock increases. As and when you complete it, that stock goes down. Room temperature, units. Okay, degree Celsius, fine. Employee morale, units. No, it can't be unitless. You have to come up with some unit. Yeah, we just come up with a. So let us keep it simple and call it say percentage. What is it? Sorry. Salary. That's not the units. I don't think so. Not everything is governed by that. Huh? Yeah. We can assume whatever morale is extremely high. We'll say okay, 100% is a morale, and then we'll. Meaning, I'm just making the scale between 0 to 100. Promotion of associate professor to professor. It's a flow. Can be number of say employees per promotion doesn't happen every day, month, maybe we'll put it a year. So we'll look at reasonable time scale, number of employees, rupees to dollar exchange rate. So it depends on how you model. So when someone says auxiliary information, you're modeling something else and you just want that information for now, and that remains constant and doesn't change with the system, then we can consider it like that. But there is no option. I have only stock or flow. So I have not given the context, but here it is like a stock. At any point in time, even if freeze now, you know the exchange rate right now. Various things, how the stocks are being traded, keeps changing this rupees to dollar, the rupees per dollar. So the units is again comes to be same as rupees per dollar. This entire units for it. So this is your ways we can actually try to quantify it. We are very cool and we are kind of very used to things which are physical, informational to some extent. Once you get into memories and beliefs, it starts becoming controversial, or rather subject lot of discussions. I may prefer percentage, you may prefer a scale between 0 to 10 or minus 10 to 10, it is fine. So we just pick up some units and be consistent with that units and how it affects your, or between 0 to 1 and make a measure and then come up with the employee morals. So this is not all, whatever doesn't have order doesn't need to be exchange rate. So whatever the expected value, whatever is the current value can continue to be a stock. Let me give another example, or let me draw it differently. Give me a minute. Let's take another example. Let's see customer demand. When you say customer demand occurs, is usually units per week, sales units per week. But then demand, when you ask a shop or when you find out, we all know the values of the demand. Okay, what is the forecasted demand for the next week or the expected order? So the expected order per week could very well be a stock, and this could be the change in expected order. So the units for this is say pieces per week, and change in expected order could be pieces per week, which is units of the stock per week. Similar with the exchange rate, whenever you go, there is a board, the money exchanger, where the value is written for you. So that is today's rate. He is not going to change it every minute for you. The rate is already given. Maybe with computerized systems, still some more updates does occur and that acts as a kind of a thumb rule for people. But at any point in time, you are able to freeze it and get that value. So in that sense, you are modeling rupees per dollar exchange rate, and rupees per dollar exchange rate, how it changes every minute we can then model as a change in the exchange rate as a flow like this, similar to this change in exchange rate, and this can be the exchange rate actually. And having done that, maybe I can give some more examples like with units. For example, let's take it as product price and change in product price. So product price is typically say rupees per unit, right? Change in product price is rupees per unit per let's assume it fluctuates daily per day. Some can change over time, over year, etc. So these also others, some of it are very intuitive. Like for example, population. Then you know, okay, population is a number of people, and birth rate is people per annum. Death rate is also people per annum. Okay, population is quite straightforward. Inventory, production. Inventory is a stock keeping unit. Let's say, or what else? Say, cases or bottles in our example, bottles. Production rate is bottles per minute. Consumption rate also can be in bottles per minute. So then this change, though the direction is only one. So some of the modeling convention dictates us to do it this one also. This is actually a bidirectional arrow. To model it. So as a change is positive, it increases the exchange rate. Change becomes negative, it decreases the exchange rate. So whether you are adding a negative or subtracting a positive, so it's better to just don't worry about double-headed arrows, just put one-headed arrows showing the direction, and so that is the direction which is getting added. So if the value becomes negative, it kind of subtracts and becomes quite